Yes. Hello and welcome everybody to our second BluBulB event ever here. I'm completely humble and I'm grateful to see so many people here again, because that somehow shows that what we are planning, that what we are organizing, that what we're throwing out in the internet seems to be somehow interesting. So thanks all for showing up. We had a successful first event about a month ago here at the same place, and a special shout out to the people that came again, because that also shows somehow what we're doing is entertaining. So you want to see a next BluBulB event. So thanks for you guys. I also want to tell you that we listen to your feedback. So we should have more control over the breaks this time, and we should have less problems with the technicalities. And I know these are famous last words. Let's see how this goes. We want to improve still, because we're still learning how to do the stuff. And that's why you find on all your tables like some small flyers with a QR code. If at any point during tonight you think like what they did is really great, or what they do could be improved, please let us know your feedback. We actually really look into this stuff. At this point I also should say we are filming it tonight. And if you have any problem because you're here with your secret lover, or you told your boss that you're working tonight, let us know and we'll find a solution. Not for the working lover, but for the filming. Then to the people that are coming here for the first time, let me a little bit explain to you what you got yourself into. BluBulB is an initiative. We are funded by the Center for Protein Research at the Novo Nordisk Foundation at the Copenhagen University. And we are 3 colleagues and we're coming from science. And we know every day there are fantastic things happening in the labs, in the offices, in the laboratories, in the workshops, in the field. And we want to bring scientists out and let you have a look into what they are doing daily and why they like what they are doing. So we invited 2 scientists tonight, and they both will give roughly a 50-minute presentation where they not only teach some stuff and not like in a seminar, but where they actually will show you what I'm doing. I like to do this because, and it's relevant because I do something with it. But we at BluBulB, we are doing not just science, because we think we also want to keep it a little bit lighter and we want to add a new take on stuff. So we also have an artist tonight performing. And on top of this, also Leonardo here is with me, who's sitting there, a little bit hidden. And she's quite skillful with a pen. She is the one that drew our blue, our logo. So she or you can see, she knows her way around the pencil. And so she will capture tonight and will listen just as you do to the presentations that we're getting tonight, and we're inspired and we'll doodle along, draw along, and we'll check regularly in with her and see if she gets the same stuff that you are understanding and if our presenters wanted to tell the same things. It's also Leonardo that we sent on a small tour and visiting all of our presenters for a 3-minute video and actually show how do they perform in their workplaces, where are their workplaces and how do they look like. Well, with this, let's go over, because tonight we have one topic that we're addressing, and this topic is evolution. Well, if you look up evolution in the Oxford Diary, you read it's a process of gradual change occurring in a system. Well, gradual change can come by mistake, gradual changes can come by intent, or they can just be a result of a very, very, very long time. And tonight we have a bioinformatician that's going to talk about how mutations are happening in our body. We have a musician that's going to develop a music piece here. And we have an Arctic researcher that will look into or will show us how a specific environment is changing and how people are adapting to this. But one thing after the other, we are starting with Leonardo, the bioinformatician, and we're first going to meet him in the lab on a small video, and after this, here on stage. Thanks all for coming.
tutti. Today I'm here at the top floor of the Mars Tower, which is part of the Faculty of Health and Science in the University of Copenhagen, where they do a lot of research to benefit science, society and individuals. I'm here at the Novo Nordisk Foundation Center of Protein Research, where they do a lot of studies on proteins and also how proteins change in time. And to do this, we are actually meeting Leonardo, who is studying how protein change using computational power. Hello, Leonardo.
Hey!
Are you working with this today?
Yes, it's DNA. You guessed it correctly.
Thank you. What are you doing? Are you a little bit busy or?
Yeah, you can see it's a lot of stuff here.
Okay. Is that what are you doing today for DNA analysis?
Nah, not really. It's not a movie, unfortunately. Here I'm just showing some alignments of DNA. It's a web browser with which we can analyze different information from the patients. And here I have a pipeline with which we align the DNA.
We finally found a nice place where to sit and chat a bit. So you say that you are a bioinformatician?
Yes.
What does it mean?
So a bioinformatician is a mix of a biologist and an informatician. So the idea is that we use the power of computers, math, statistics and coding to analyze biological data. It can be DNA, proteins and also patients' data and etc.
Why did you join BluBulB? A little bit on the wave of this?
Yeah, kind of, because I also like the idea of being able to simplify complex topics, and it's communication ability that is very valued. And I also think because it's a very cool project, the idea of bringing science from the labs to the people, right? Because at the end of the day, it's also the people who pay the science with their taxes. So they also should get something in return, right?
What you are gonna show us tonight?
So tonight I'm gonna talk about alcohol, because we are in Denmark, we're in a bar. So I'm gonna talk about how we process the alcohol that we drink and how different people process alcohol differently.
That sounds interesting, and see you tonight.
Good evening, everybody. I can see that pretty much all of you are having something, I presume, alcoholic. Well, I didn't have anything yet, because I can get quite tipsy after just 1 or 2 cocktails. My friend can witness it. But, have you ever thought about why different people react to alcohol differently? What do you think are the factors that can influence this? Nobody's answering. Maybe you need to drink a bit more to be less shy. But I can tell you that, for example, well-known factors are age, weight, and sex. And by sex, just to be clear here, I don't mean how much sex you have, but it is known that there are some known differences in how males and females metabolize alcohol on average. But sometimes, apart from these factors, other things are the differences are lying in our DNA. But to explain this, let's first see what happens when we drink alcohol. Our body essentially wants to get rid of alcohol because it's a toxic thing. And it does so by converting the alcohol into another molecule, another toxic molecule. Don't ask me why the body thought it was a good idea to convert alcohol to another toxic molecule, but that's our body, right? But yes, this second molecule is indeed toxic, but at least it doesn't make us feel drunk. However, it's also one of the main responsible factors for all the side effects of alcohol, like headache, stomachache, and the most feared hangover from the day after, right? And I think that most of us can have had these experiences in our lives. And after converting the alcohol into this second molecule, our body finally converts it to a third molecule. This one is non-toxic and can be finally eliminated easily by our body or reabsorbed. And all these processes here are made possible by proteins. And different people can react to alcohol differently because of differences in these proteins. But what does it mean? Well, our body needs to build these proteins from something. And our body uses DNA as the manual of instruction. You need to imagine DNA as the manual of instructions to build everything that is in our bodies, including proteins. And sometimes people have differences in their DNA, and every cell in our body needs to copy this manual of instruction. And this DNA is not written in English, it's written in a weird language with only 4 letters, A, T, C, and G. And these 4 letters represent 4 different molecules, the 4 different building blocks that build the DNA molecule. So, our body needs to copy this DNA. Our cells, when they divide, needs to copy this DNA, so the new cells will have the same manual of instructions. And let's see here an example of how does this work. This process is again made possible by another protein. And here, let's pretend that this is a piece of DNA here. This word, of course, when it's written in English, this word this piece of DNA means this word beer, and the beer is kind of the protein that this DNA has the instruction for. And here, let's pretend that I am the protein in the cells trying to copy this DNA. So I read my template, I take my boxes, my building blocks, I put a B, what's next? I put a E, I put another E, and I put R. Actually, I'm afraid I made a mistake here because I put by mistake an A instead of an E, and we can all agree, I think, that beer and bear are have quite different meanings, right? You generally run from a bear, but you definitely run towards a beer. And so in the same way that Einstein added a mistake in the meaning of this word, mutations in our DNA can change the version of the protein that we have. And these can help to explain why different people, for example, can metabolize alcohol differently. And why, but, mutations, let's go back in the DNA, mutations happen randomly in our bodies. And how can I say? I need to check it because I got a bit stressed. I should have drank a bit. Yes, okay. So this was to bring me to the next point. The thing is that nature is not perfect, but that's why mutations happen, because the protein that makes this DNA replication process is not perfect. It's like us in an office when we need to write an email, for example. We can make a typo, we can make a mistake, so it's a mistake that can happen by itself. But sometimes mutations can also be driven by external factors like smoke, radiations, chemical mutagens. And this is an analogy, me in the office getting distracted by a chatty colleague while writing an email, for example, right? And so this helps to explain why some people can metabolize maybe alcohol faster and some others more slowly. And this helps to explain why some people can tolerate alcohol quite good, yes, Sebastian, and some other people a bit less. Literally 2 weeks ago. So, the same mutations can also help to explain a weird syndrome that I don't know if many of you have heard of. It's called the alcohol flush syndrome. People with this syndrome, even if they drink a moderate amount of alcohol, they experience very bad side effects, nausea while they drink alcohol, not just the day after. They can get headaches, stomachache, and the most characteristic feature is that they have their body and especially their face flushing red. It's very common in East Asians. Around 1 every 2 people in East Asia have this syndrome. And then it's also why it's called, in a less flattering way, Asian alcohol flush syndrome. But we also have it in Caucasian Western populations, although more rare. Like only 1 every 2,000 people have this syndrome in Western populations. And so as some people should not drink too much alcohol because it's bad for them, some other people should not eat too much sugar, and especially patients, people who suffer from diabetes. These people have, their body cannot produce insulin. Insulin is again a protein, and this protein is needed by our body and is produced by our body to regulate the amount of sugar that we have in our blood. So these people need insulin from an external source in order to survive. Back in the 1920s, we used to extract insulin from pigs. Around 1,000 pigs were needed to extract the amount of insulin contained in 2 vials of insulin, around 1 month of treatment for a diabetic person. And apart from killing pigs, the other problems is that the pig insulin is not perfectly the same as the human insulin. These are 2 versions of the same protein, and so in some people the pig insulin causes severe allergic reactions. Luckily, science advances. Around the end of the 80s, scientists figured out which was the exact DNA sequence that codified, they gave the instructions to build 100% human insulin. And they were able to insert this DNA. They were able to insert this DNA that of the human insulin in bacteria in the same way that here I have this DNA and I'm just inserting all the pieces, and from beer to bear to beaver, to give yet another set of instructions to this DNA. So this method of production of insulin solved the problem of the pigs, and also of the not having the perfect 100% human insulin, and significantly decreased the cost of insulin production. And here in Denmark we have a big example, Novo Nordisk, one of the global leaders in diabetics care. And Novo Nordisk, together with also other company, now are even taking a step further. They studied the insulin and they add new mutations, not just 100% human insulin, but just even new insulin that didn't exist before, in a way to give it more different properties, with the final goal to improve treatment of the patients. So, in conclusion, I just wanted to highlight the importance of studying DNA and studying mutations, because it literally changes lives and saves lives. And on a more lighter note, don't mock your friends who do not tolerate alcohol. It might be simply due to their DNA, it's not their fault. Thank you.
Thank you, Leonardo.
Thank you.
Thank you for giving me an explanation why my headache last Sunday was actually not my fault and not the red wine's fault, but purely my DNA, so I'm quite thankful for this. Are there any questions for Leonardo?
Yeah, of course. Is there any research ongoing to create a DNA, something that gives you the protein that you lack to tolerate alcohol more?
Actually, yes. I mean, they commercialize. Do you have it?
It's always a useful.
But apparently, Googling this, I had to study this, right, for this, and apparently there's, I don't want to do advertisement, but there's a company that it's a supplement, just pills, and they give the enzyme, these proteins that are needed to avoid all these side effects of the alcohol first. So if you want to know the details, just write me so I will not make advertisement.
What is the stock market ticker of the
I don't know if they're listed on the exchange.
Yes, so very important question there. Thank you for asking that.
But I guess if everybody is here and is drinking alcohol, I think that nobody has this. But maybe you have some friends who have it.
Yes. We have time for another question, if there's any. Doesn't seem to be the case right
Drink
now.
more, drink more.
Oh yes, there's one, please.
Yeah, you talk about mutations. Do you think they are so important?
Without mutations, there wouldn't be any change, and so
Yeah,
no
but,
evolution.
well, I'm working in a hospital and we're sequencing resistant bacterial genomes. And we don't fear mutations, we fear when they transfer DNA to each other. That's the thing we fear.
That's because of mutations in the bacteria, right?
No, it's because if you have Staphylococcus aureus and it gets a small piece of DNA from another bacteria, it will become MRSA, and then we have the problems. So it's actually the transfer of DNA between bacteria that are the big problem at the hospitals, not the mutations.
Yeah, horizontal gene transfer is a bad thing for us because it gives. But in this case, I would just want to focus more on humans. But we should fear and not fear everything. We just need to have more knowledge about what is around us and what is inside of us, so we can have better outcomes.
Yes. Thank you for the question, and I think that's something we're going to dig in deeper, because if you don't have a question not yet for Leonardo, or you want to ask later, we're going to have a small talk round in the end, where we're going to exactly look a little bit like, is change, is evolution something we should be happy for or should be scared of? So, and I hope we can dive deeper into this one. I think we should give another hand to Leonardo. Thank you very much. Yes, so Leonardo talked a bit about the change from bear to bear and the adding of the beaver. And our next contributor tonight, she also going to work with adding. And we forgot Leonardo.
What about Leonardo?
That never happened to me before. Leonardo, can I get you into the light then again? I have to apologize. I was so excited to move on to the next bit.
I'm not the only one making mistakes. That's good.
So let me ask you, Eleonora.
What did I get?
What did you get out of this one?
So, what I get, like Leonardo talked about a little bit of different population that I really try to summarize with different silhouettes, and you can actually understand which kind of people like different part and whatever. Anyway, he also said that most of the difference are in our DNA, right? And our DNA, it's a little bit like a dictionary, a manual, what did you
Manual
say?
of instruction.
A manual, so I put just beer and beer, because at the moment I didn't realize how many words we have, so I just remember beer and beer. Anyway, so we also say that, like, you know, we have transformation from a compound to another compound, and this compound is usually toxic because our body does strange things there.
A lot of fantasy drawing the compounds with the windows.
Like I had to think about the compound, but then I was like, I'm just somewhere out there. And then I drew a beer, of course. That is a beer, because you know, beer are usually having beers. But I also drew a beer having.
That's fine.
Because I was just like, you know, I cannot keep, like, I also forgot a hand here. Now it's saying something like, hello everyone, I'm having a beer. And also talk about a little bit of like vegan that they were using DNA for, like, you know, the insulin and all the stuff. And then they use bacteria. I think I like throwing bacteria everywhere. Then we had a question from the public. No, wait.
What do I have in? Okay, so, that's me.
Yes. So actually, we had a question from the public where someone was asking about maybe we can fix this problem with the alcohol. So this is a pill, and this is someone that is drunk. It was not you, Leonardo, but anyway.
The resemblance is uncanny, though.
Yeah, kinda, right? But yeah, this is what I get. I think I hope I get it right. Yeah. But
very talented.
Thank you.
Nice.
What are we thinking in the audience? Like, did Eleonora catch a little bit what you understood?
Of course, with this one, definitely.
It is amazing. Like.
Good. Am I now allowed to continue?
An applause.
Yes.
An applause for Eleonora. Good. Let's try again. Trying to make a point that we talk about changing and adding, and then our next contributor, a musician, she's also going to be changing and adding elements in her music piece. And she's going to do this by a technique called looping that I think many of us might be familiar with, where you record yourself and then you re-record yourself and then you re-record yourself again, and you switch off and on different pieces in this one. I also already got like a glimpse of what she's doing. And I think our example of the beer, the bear, and the beaver might be a starting point in this one. But we need some time to set up her system here that everything is working. And I think you need to have time to reset your drinks. So we're going to have a 10-minute break, and then we start with the video from Sonia. And after this, we're going to see her performing here. Thanks, everybody.
Let's see, today I'm here in Ama to meet Sonia. She's an athlete, performer, and also a music maker. And today we are gonna see how music is done, and we are gonna meet her in her place, in her house. Let's do that. Hello, Sonia! Sonia, when did you start to play music?
I started playing a little bit when my mom had a Spanish classical guitar.
Okay.
Hidden at home in her hometown, and then she gave it to me, and then I started playing like some chords and notes. I was having like a couple of private classes, but that wasn't very sustainable in my house, so I just learned the very basics, and then I started from there.
So it's like guitar your main instrument, or you have other instruments?
No, I have more. Actually, like I'm trained as a violinist. I started playing the violin when I was 13, 14.
Why did you join BluBulB?
Because actually it's a very cool project. I like the idea of bringing science to a wider audience for people like me to understand. I'm not like, I mean, I'm interested, but I don't know the technicalities of it. I don't know the language. Because there are a lot of words that I don't know, and I find it that projects like this, it just make, I don't know,
Things easier
Yeah.
to understand, and
Yeah.
maybe also putting some music there will be more like.
it's a lot more, how to say it, it's not like so boring to go in one place and just to be just like listening something for several hours. It's like very dynamic.
What setup are you gonna use it tonight?
So I'm working with Ableton tonight. Ableton is in my computer, and it's where the magic gonna happen. Then from there I'm gonna use a keyboard, which is also connected to the computer, but I'm not using it as an instrument, I'm using it as a MIDI controller. So I have different pianos or sounds in the computer, and I'm just using the piano here just to modify them. Then I have a little group box where I'm going to be triggering sounds, and I'm going to be triggering melody. That one I use as an instrument. Then I'm going to have a little launch pad, which I'm going to be controlling. It's like my fingers in the computer.
What are you doing tonight at BluBulB?
It's an audiovisual trick. So it's a mix of video, music, and there's going to be a story from beginning to end. And it's going to start one way, and it's going to be evolving because we're talking about evolution, and then it's going to be finished another way.
And you get your expectations super high. But I show you that evolution can go very well or very wrong. Let's decide that.
Whenever you're ready, Sonia.
Okay. Bear, beer, beaver. Bear, beer, beaver.
The bear was at the fire. The beaver had been out on the fire, but the fever disappeared. The bear couldn't get like his friend was longer saying. The bear had to stop drinking beer with the beaver. The bear was at the fire. The beaver had been out on the fire, but the fever disappeared. The bear couldn't get like his friend was longer saying. The bear had to stop drinking beer with the beaver. The bear was at the fire. The beaver had been out on the fire, but the fever disappeared. The bear couldn't get like his friend was longer saying. The bear had to stop drinking beer with the beaver. The bear was at the fire. The beaver had been out on the fire, but the fever disappeared. The bear couldn't get like his friend was longer saying. The bear had to stop drinking beer with the beaver. The bear was at the fire. The beaver had been out on the fire, but the fever disappeared. The bear couldn't get like his friend was longer saying. The bear had to stop drinking beer with the beaver. The bear was at the fire. The beaver had been out on the fire, but the fever disappeared. The bear couldn't get like his friend was longer saying. The bear had to stop drinking beer with the beaver. The bear was at the fire. The beaver had been out on the fire, but the fever disappeared. The bear couldn't get like his friend was longer saying. The bear had to stop drinking beer with the beaver. Beaver, bear, 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 beaver, beaver, bear.
Wasn't that bad. It was okay.
I think we can see that was fantastic. Like I didn't dare to break the silence because you brought us to a complete new mood and a complete new place. Thank you for this. I think that just directly deserves a new applause. Though it's maybe harder to ask questions to artists than it is to scientists, I still want to give the opportunity to the audience if there are any questions for Sonia, the musician. And if this is not the case, there's one.
Sorry you couldn't see me that much.
I think I got ahead of it. Luckily, you're not as tall as me. So I was wondering, do you see this as a positive or a negative note of discussion on evolution?
I was going to say the performance.
That was great.
Evolution. You know, it's very funny because it's not a thing that I wake up and I think about it. Like, I mean, it's good because it brought us where we are today. I don't know. I'm like.
But only if you have like a mood in mind when you created this. If you didn't have it, you just say no.
No. I think it's good. I think I like it. It's just like I like
the idea of something evolving for the better, not for the worse. I don't know if that.
It certainly does. Thank you.
Okay, thank you.
Yes. Then, if there's no other question right now, again, we have late the chance to ask Sonia. I also might have some questions for you. That's and about music. I think they are also clear expert in. But this time I remember,
Thank you.
Eleonora, did you get something? Did the music inspire you to draw something?
Yeah, let's see. So we are back with our beer, drinking a beer with a beaver here. So they are together and they're thinking, I imagine them discussing in the bar together what they are doing and thinking about the weather in Denmark, because this is the only, probably I wrote correctly weather. And then it started a little bit the trip that like Sonia brought us. So it was from the drink, right? You just went inside the drink and goes down. Yeah, I'm drawing. I don't see it.
That was the original idea. Now the bear throws a beer to the beaver.
Okay.
Everything
So-
very realistic.
And you brought us like a little bit in a kind of environment with fish and all this stuff. I think that was a coelacanth also there. Nice. But then I start to trip a bit too.
Like me.
Yeah, could be. A little bit of evolution, and I'm always thinking about like cells, and like then I go to pluricellularity, so cells together, you know, and then here there is our little embryo, let's say, and then it became a little bit bigger, and then it became a beaver that you cannot see it, and then he goes to with his friends the polar bear to drink a beer. So this is what I got. I think there was much more powerful message there, but this is what I got.
Sweet. I think you were really trippy on this one, I can say.
A bit.
A bit. Beautiful. I think with this you achieved something. I think you can be proud on this. Thank you so much for your music. Well, Sonia here left us an environment that's also undergoing a big change. The Arctic, that was the last picture we saw. And our next presenter will explain a little bit what are these changes that are happening there and how are the people living up there being affected by this, dealing with this in different ways. And we're also going to hear a bit like how the changes can be challenges, can be risks, or can be something positive, because also changes trigger some changes and trigger some improvements in the future. But we need to reset the scene a little bit again. You maybe also need another drink again. I see many empty glasses, at least in the front row. You are really good on that. So please feel free, go to the bar, have another drink, and in 10 minutes we continue with our last speaker, who coincidentally also is called Sonia.
Guys, today I'm here in DTU in Lyngby, where they do a lot of interesting stuff and like applied science and data science and a lot of stuff. But today we are in particular here to understand how buildings for the Arctics are done. Let's figure it out. Hey Sonia!
Hi.
How are you?
All right.
Alright, is there where you work? Building 118?
Yes, this is the building of our department, but actually I'm in the building just behind, which is a bit hard to find, so I will guide you. So here's the geotechnical lab. Here we do analysis of geotechnical properties of soil. Now we go into our sample storage room. Most of the permafrost samples are stored in this room, and they are, as you can see, at minus 10 degrees. Sample of permafrost, like the one you will be soon touching in the audience. So they are well wrapped. You can see here is the actual soil with ice in it. The dark part is ice, and the brown part is the soil. So there's quite a lot of ice in this sample. and it is wrapped in plastic so that we don't lose any moisture from the sample. And then it is marked with the location. Ilum is for Ilulissat. The sample was taken in 2018 and it's the third borehole that we drilled. That's the sample number and the depth. So this sample was taken from 2.2 meters in the ground. Our drilling equipment. It is the instrument we used for getting those cylindrical samples I just showed you in the freezing storage. So because the soil is frozen, we have to use some heavy duty equipment to get in and get our samples. So we use this cutting part, which is also extracting the sample. These are the drilling bits that you attach at the bottom here. And they are the ones that actually cut the soil, and your sample then comes in here. So the way this works is that you have it in the soil, you have an engine attached here, and two people hold it, and this then is cutting the soil, and your sample comes out from the inside.
Sonia, we finally found a nice place where to sit, better than the freezer, right? So, do you prefer to work here on the computer or in the freezer?
I think I like the most to work in the field. It's because it is exciting and there is a lot of planning work involved, a lot of work with the team, so that is the most exciting part for me. And then I also like to actually look at the data and try to get something out of them in the computer.
How did you start to be interested in this kind of science, geophysics, right?
Yeah, I don't think that the geophysics was what got me in. I think it was the love for the nature and adventure and traveling that got me towards these topics that actually helped me to bring me there.
What are you gonna say to us tonight?
I think I would like to communicate the changes that are happening in the Arctic to people in Denmark that perhaps don't experience it so acutely, and also to invite them to consider the positive and negative aspects of changes.
So Sonia, see you tonight.
Yes, so thanks for coming tonight. I would like to, after the immersive audiovisual journey that Sonia took us on, I would like to take you on another kind of journey, this time into some parts of the world that are among those that are changing the most nowadays. Yet a lot of these changes are actually quite invisible until it comes to the point where the consequences can be quite drastic. So as you see in my introduction video, I work on the research in the Arctic, and I look at the changes that happen under the ground surface as a result of changes above the ground surface. And I work with this particular ground material that I mentioned several times. It's called permafrost. Has anyone heard of this before? Fantastic, I don't have to explain, so it's not only me. So between context, what is it? Anyone, just tell me, what is the first thing that comes to mind?
Ice.
Ice?
Yeah.
Ice where?
It doesn't thaw.
It doesn't thaw, where?
Like ever, right?
Is this permafrost?
No,
Why not?
if you go deep down, it's probably...
It is ice.
Yeah, but it's permanently frozen ground.
That's a good point, yes, because I said I work on the underground, yes. So permafrost is ground that remains frozen. And this is obviously because in the Arctic we have the winters that are pretty long and pretty cold, and pretty. It means that the ground is frozen through. And then what happens in summers are actually also quite warm. They can get quite warm in the Arctic, like in Greenland we get usually days 20 degrees plus, and in Siberia you may have heard that in summer there are days that have 30 plus degrees. But the thing is that the summers are quite short. So during the short summer, it is only the top part of the ground that, I have a pointer, that thaws. And before more of the ground may reach to defrost or thaw, as we say, the next winter comes and it freezes up again. And you have this portion of the ground that never thaws, never defrosts. And this is the part which is called permafrost, and that's the one we are looking at. And I have a treat for you tonight. I have a sample straight up from Greenland. So because it's, as I say, permafrost is in the underground, so it's a bit difficult to get to it. There's also sometimes some unfrozen soil on top of it. So you have to use that equipment, as you see in the video, to get samples of it like this. And I will let it go around. And we just took it out of the freezer, so it's slowly thawing, defrosting. But I would like you to notice while it's in its original condition, as we took it out of the ground in Greenland several years ago. And I would like you to look at two main things. There is the dirt, the soil in it, and there are the glassy parts. That's all the ice that is in the soil. And that's the ice that is naturally in the ground, in the areas where we have permafrost. So I'll let it go around slowly. You can touch it, you can get your hands dirty.
Put some napkins there because you will get dirty if you touch it.
Then pass this as well. It will slowly go around and let's see how it returns to us. But it's okay, it's dedicated for this evening. If it gets destroyed, it's fine. Now there is one little misleading thing in this name permafrost. It is made of two words, permanently frozen, permafrost. But it kind of seems to imply that things are stable, they are not changing. And that is not quite true, because the ground is changing in the Arctic, and it's actually changing quite a bit. And what happens when permafrost warms up and thaws, you get something like this. So this is another sample that started like the hard frozen one that is now going around, except that this one we let it outside of a freezer for maybe 2 last hours.
Please don't send it. Yeah, man.
Yeah, I thought I would, but anyways, you can come and have a look at whatever's left when I'm finished. But there are two main things I would like to notice when you come up and look at whatever's left. You can notice that all the ice that was in the soil has melted, has turned into water, and the shape of the sample has changed quite a lot. I would like to ask you, do you know what happens to, there are two main things that happen here with the ice in the sample. And it's the first thing is the volume change. What happens to the ice when it turns into water? Shrinks, yeah. It changes volume, it reduces volume. And the second thing is once you have water that is in its liquid state, it can move in the soil, in the pores of the soil. It is mobile, it can flow. It means we get twice a change of volume in the soil when it thaws. First is the 10% volume reduction when ice changes into water. And second is if the water disappears from the ground, we get another volume reduction equivalent to the water that has flown away. So when this happens in the Arctic landscape, in the landscape where we know we have permafrost underground, when you have these volume changes, they show up on the surface. If you have a volume change, the volume reduction, the ground surface will deform. And that's fine as long as we don't have some human structures put on it. If we put a road, or if we put a house or any other infrastructure on top of a ground that is changing changing its volume, things like this happen. And this is a photograph of a road in Ilulissat. Ilulissat is the third largest town in Greenland. It has 4,500 inhabitants on a normal day, and it has about double of that on any busy touristic day in summer, when tourists from cruise ships disembark. And this is not just a road in someone's backyard, as it may look, because it's quite small and wonky. This is actually a key piece of infrastructure in this third largest town. This is a road that connects the town to its airport. And this is where there's a lot of traffic. And it's in this state. And that's because we know that we have studied this landscape, and we know that we have permafrost with a lot of ice in it under this road. So we can attribute these changes to thawing ice under the road. You can imagine if you put a dark road on the surface of the ground, not only you have effect of whatever climate warming that's happening, in addition to that, you will have increased heat intake from all the sun that is heating up the asphalt, that is heating up the ground further. Now, I'll return to this. You see, I say there's a thawing of ice going on, but you don't see any water. And that's because this is a landscape on a slope. So all the water that you see there can just flow away. This is an example of a community in Alaska, which is on a very flat ground. Here, the water, once the ice melts, the water cannot run away. So you have the communities in the Arctic who have these issues where in summer, they cannot actually walk between the houses because they are floating in this wet, squishy tundra. And it's a big issue because then they have to put up boardwalks made of plastic to be just able to go to their neighbors. Another thing is that if you have a landscape, this is this dynamic, this is changing this much, it's really difficult to build some of the very key pieces of infrastructure that we take for granted, like sewage system. You cannot quite put it into the ground because it's frozen, and also it is changing with freezing and with thawing. And you cannot put it above the ground, definitely not, because it will again, the pipes will crack and they will disconnect and you may have sewage leaking everywhere. So the towns like this often don't have the very basic pieces of infrastructure. So what happens here, the residents, they just dump the sewage into the river. And because this town is in such a flat ground and the river is close to its delta, it's ending in the ocean, every time there is a high tide, the sewage flushes back into the town and floods it. And actually the kids in this village, they have done a school project. They went around the town, they collected the samples from the ground surface, and they measured the E. coli bacteria presence, and they found it everywhere in town on the surface. So how can it be? Oh, it's a bit slow. Are we? So how can it be that we have, if someone can help me to switch the slide, I'll continue in the meantime. How can it be that these communities, they have lived in this area in these localities for quite a while, but these houses typically date from perhaps 50s or after Second World War. How can it be that at this time we built such unsuitable housing and villages for these people? Well, the one thing to consider that we didn't know everything we know today. This is, again, a picture from Greenland, from Sisimiut. It's the second largest town, and it's from the 30s. You can see how people used to live traditionally. It's an old picture, so I'll try to explain. These are, in the foreground, there are the traditional Inuit houses made of peat. The walls are made of peat, which is very good thermal insulating properties, so they're very good to insulate them against cold. And they have wooden roofs. There is almost no paved roads, and all of the structures have a relatively short lifetime. So you don't quite realize the problem you have when you don't build larger structures or when you don't build roads. Then after the Second World War, from 50s onwards, more development started, larger buildings started to be built in these areas, and that's when people started to really feel the problem with permafrost. They didn't know yet where to find it and where to try to avoid it. So they built, in this case, a grocery store, a pretty large building, right on top of an ice-rich permafrost. Now, what happens if you put a building that obviously for comfort is heated in winter on top of an icy ground? That happens. And it happens faster than any climate effect would. So this building, just 15 years after it was built, it had to be decommissioned and torn down because it became a hazard. It was so much deformed that it started to fall apart. One of the ways to try to counteract this problem is to put houses on a little stilt. So you see, this house is not touching the ground, so we limit the amount of heat that comes from the heating of the house into the ground. So that's good. But I still don't think any of you would pick this house in a catalog to have it built for yourself. It is in a pretty poor shape because there is a multitude of other changes. We have to realize these people live in the communities that are very far, in very extreme climate, isolated from each other. We cannot take a car and travel to the next village in Greenland or in Alaska or in Siberia. If you want to build a house or make any repair, you have to plan quite long ahead, sometimes a year ahead. Order your materials, have it delivered by ship. You better not forget anything because you have to wait several months until you get another supplies. So whatever design ideal house should have, it also has to be relatively cheap and easy to build. The good thing is that the people are quite resourceful with coping with these changes on a day-to-day basis. Again, an example from that flooded village in Alaska. Actually, the situation with the permafrost thaw in Utah, in this town, has got so bad that the entire town had to be moved to a new location because it literally started to sink and started to be flooded. So they have built the new houses and moved, slowly are moving all the residents to another location. But in the meantime, obviously, people will not be happy with tilted houses, so they try to do the best they can with the resources they have. So here they try to level up their foundation, because you can imagine in a tilted house, everything is like on a rocking ship. It's not very comfortable to sleep in a bed like this or eat from a tilted table. Yeah, so that's a piece of workout equipment under a bed if it's not. Now, oops, yeah, it either works too much or not at all. So this is great to see. Like, we can see that the people are extremely adaptable. They pretty much can deal whatever you throw at them. But should it really be like that? I mean, it's a lot of hassle. It's a day-to-day small patch-up adjustments. And what we lack in this region is a systematic approach, how to build better houses. And that's what we are trying to contribute as scientists. We're trying to understand how the climate, how the ground interacts, how the built structures interact. How can we reduce the effect of the buildings? How can we design them in a more sustainable way and in a way they can cope with some of these changes? Or as a very first step, we can just delineate or find the areas that are safe to build and that are not safe to build. So as a first step, it's good to understand the landscape we are living in. I'm not sure if it strikes you in this picture, but you can see that all of the houses are on the left side, and then we have a road, and then there is nothing on this side. Any idea why that is?
Water flow?
Yeah, that's actually a good point. Yes, that's part of it.
The rocks,
Yes. How do they come into play?
because they will not change.
Exactly. So this is something that people in Arctic and in this case in Greenland, they know very well. The safest ground to build on is rock, is the bedrock. That one, even though it changed temperature, it will not change the shape or strength. It will remain a good foundation for the house pretty much no matter the temperature. So that's why in Greenland they put as much as they can all the houses, all the key infrastructure on bedrock. And you can see this is a landscape very similar to one we saw in Utah. In Alaska, there is some water ponding here, a water that cannot flow away. There is a lot of vegetation, a lot of soft ground. And I think only from the pictures I show you tonight, you can guess that this is not such a suitable terrain to build in. You still have to put the roads somewhere. Obviously, they cannot always be on the rocks because you have this landscape with rocks and soils, and they are the ones that get sacrificed, and they require a lot of maintenance. But at least the people's houses are safe. Another step you can take is to design your houses in a new way. So again, we are going to Alaska, and Mertarvik is the name of the new village that people from Utah, the flooded village, have been moved to. And there was a great care taken in choosing the site for the new village, because obviously it's very uncomfortable for people to move all of their belongings, all of their life, to a site which has no history and they have no connection to. So first, the scientists chose a good site that we expect will remain stable for a sufficiently long time. And then they have built houses with a special foundation. As you can see, the foundation is raised, so the house is not touching the ground, so that's good. We limit the heat from the house heating into the ground. And the next thing, it has several nice adjustments. So once you put the house on the side, you can actually adjust it with a screws, and you can level it to make it perfectly horizontal. And in case the ground still starts to move or settles, there is at least some room to level your house for some years to come.
That sounds like a great Friday night plan to just start jacking up some neighbor's house.
Well, and in case you are get bored of your view, this house actually is built on, the foundation is built on skis, so you can actually just drag it to a new place.
In your neighbors.
And the last example of how people are trying to get creative and adapting to these changes and using this change to actually stimulate new inventions and new ideas is modular houses. So you can imagine, especially in Denmark, that the most expensive part of your house or apartment is bathroom and kitchen. All the installation, all the special care it takes to build them and to maintain them. It's similar in Alaska and in these remote communities. It also requires quite some specialized skills to build a bathroom and a kitchen. So what this project suggested, the container modular home, is that they put the expensive part of the house into a metal container, because that one can resist some movement of the ground. It can also be assembled on a site where you have the qualified people who can make the plumbing work, and then you can ship it to the final destination where the local carpenter can build the less expensive part of the house, the wooden living room and bedroom, and you can actually extend your house as much as you please. So this is a prototype in production. Yeah, the container on the wheels, and before the bathroom is actually fitted in.
Bigger than a Danish bathroom.
Yeah. Yeah. So, yeah, where do we go from this? I think I'm not the one to talk about climate change as much, but I had to show this picture because what it shows is that, well, we have now moved from the year 2000, but what I want to show, when we were around here in the mid of 1900s, we didn't know as much as we know now. The houses, the infrastructure we designed in these areas are perhaps not the best, and also the environment has changed a lot. Now we are around here, and we know much more. All the knowledge, all the science that we have assembled gives us this foresight into the future. We know that depending on you may know this picture, depending on the greenhouse gas reductions that we are able to achieve, we may reduce the global warming or constrain the global warming to some degrees. I said at the beginning that I will take you on a trip to places that are changing the most. You can notice that the most of the change is actually happening at the poles and in the Arctic, and that's from these figures. But now we know what expects us, whichever way we end up taking. So we have the possibility to actually think up of these new solutions and adapt to this change that we can predict. Because people in these Arctic regions, they are not living in a museum, they are not living in a national park. They want to also have a modern life. And yeah, some of the science we're trying to do hopefully can help to get them there. Thanks. Don't forget to stop by here before it completely disappears.
I really want to touch it, but I did this just before, and it's really not a good idea.
Those who want to touch you.
It's not dangerous for anybody to know. Sonia, thank you so much for taking us on this trip. I think it was also something to see like how an evolution environment can be approached in different ways, as a threat or as a chance. Do we have questions for Sonia right now here in the audience? There's one back there, yes.
I was just kind of curious about the design of these like new communities, taking into account kind of these changing environments. Like, is it kind of a collaboration with the community about kind of what they imagine, kind of taking into account what has happened in the community and what they want to see changed about the building structures as well?
Yes, so that's obviously the ideal example, and that's most of the research or research projects or of these test house projects, they take exactly that route. They work with the communities, design the house based on how people traditionally live their life. In Greenland, there has been, so the examples of those houses I show are from Alaska, which are not my designs. I work mostly in Greenland. There oftentimes, in the past, there was the approach taken where the people would come there and tell people how they are supposed to live. So they would design houses which didn't quite suit the way people lived. The houses would be too small. There would be no place to bring in your hunted animals and skin them, and people would clog the bathtubs with the blood in the apartments. So that was not exactly housing designs that were suitable. Nowadays, that's exactly the approach that the researchers are taking. They bring in the knowledge of the processes, and they take the knowledge from the people about what is best suitable for them and how they interact with their environment. And that's the way how to, hopefully make better choices. Yeah.
Thank you. If there are further questions, I would like to put them at the discussion, which we're going to have in a couple of minutes, because first I would like you, Eleonora.
Because you already see what I have here.
What? Really? There it is.
So, as you can imagine, like the first things that I heard was ice. So I think I drew this, which you can imagine what it is. And it's completely not related with the talk, but I think it was
Is Leonardo DiCaprio somewhere on this picture?
No. No, but there is something else. So then I think one of the first things that Sonia said to us was like the drilling stuff, and she was very, very into like this object that they are using to retrieve permafrost, right? And the thing was nice that she gave us some permafrost. I guess we all have these same thoughts of how to touch it and why to touch it and why it was maybe better not to touch it. So yeah. Then she talked about like the ice, and how like ice is like the water is changing volumes, like when it becomes like liquid, and she showed us this amazing hole that it was all a little bit like moved, right, because of the changing of the soil. Then I have a passion for bacteria, so you mentioned Escherichia coli, and so I was just like, okay, then I have to grow it. And then you told also like about the timing, that people have to put the things, buy the stuff in time to build their house, and they also move a city. This should be a city, but I don't know if it's a city, because it's a city that is moved. And you also talk about a supermarket or something similar, that it was like in this shape and they put something under at some point. But the best things is that the stone and the rocks, right, and they don't change it, so they try to build stuff there. And I also really like when you mentioned that they have bathroom in boxes. I do bathroom in a box. And that's all.
Fantastic, Leonora. Sonia, did you ever see your science, your research illustrated in that way before?
No, and I must say I just got an idea. Maybe I want a copyright for this, and I will use it as the next. Instead of a slide, I mean, aren't we all bored of PowerPoints? I will use this and, zoom into the different sketches and then explain on that. Thanks a lot.
Yeah.
Our services are available for a reasonable fee.
Next grant application.
Good. Thank you for now, Sonia. Thank you so much for
Thank you.
So we went through a whole evening and through 3 presentations, all circled around evolution, and not once did we mention Darwin. So the origin of species is not the only thing that evolution can mean, and I hope that we could open your eyes tonight a little bit for this. Evolution can be small changes in our DNA, in our body. Evolution can be a music piece becoming larger, different, bigger, longer, and staying in root. And evolution can be relevant for a whole society and for a whole part of the world. So I want to say, I think we haven't completely exhausted yet all these things that evolution can mean. And for this, we're going to have all 3 speakers, all 3 contributors from tonight on the stage in a moment again. We just need to reset the stage a little bit. This time you only get 5 minutes because there's not so much reset. And that should still give you the chance to either get a drink, use the toilet or something. And at some point when we are sitting here, we're going to start. Thanks for now. I love the power of a clock of a bell that just like gives you the authority to make people calm down. Beautiful. Yes. The guy that's still talking is a good friend of mine, Thomas. Welcome to the discussion. Hello, hello. So the four of us found a way on the stage again because we want to look a bit more into this idea, like what is evolution? Because the three presentations today were very different, I think. But it is something of change. It is something with stability. It's something that lasts a long time, that can happen quite quick. And I have a small exercise for all of you. For 2 minutes, I would like you to start discussing at the tables with your neighbor, with your neighboring table, and think about, after the 3 talks we heard tonight, do you think evolution is something good and a chance? Or do you think evolution is something bad and it's something like a threat? And I know it's a very big one. I see somebody laughing there. Please feel free. Our speakers here will also think about this one. And in 2 minutes, we take them in and see what they are talking about. Good. We don't want to be aggressive. Beautiful. I could see there was a lot of discussion going on the tables. I don't know about what, but I want to be positive. We talk about exactly why did I interrupt it? Because we have 3 experts here on stage, and I want to give them first the word of answering the question I asked you before we're opening for everybody in here. So evolution, risk or opportunity? Leonardo, we haven't heard you in a while. What do you think?
I think it's, we tend to simplify the reality, but reality is way more complex. It's not just black and white. It's kind of 50 shades of complexity evolution. And sometimes evolution is good, sometimes it's not. For example, the evolution of these new straws here, on one hand, it's good for the environment, but they literally don't work like log and everything. So it depends.
Yeah.
That's a key secret answer to anything.
It depends. It's very diplomatic. Yes, thank you. Sonia, like in music, like if music is very monotonous, nobody will listen to it. If it changes all the time, it's not good. How important is it?
I mean, there is always reference, because I'm a classical musician, and I always have that, but of course you adapt it to contemporary kind of years and stuff. And you add more instruments, and we have new technologies now. So in my case, technology is something good because you have something from the past, and then you add something like new, and it's just great. But yeah.
Okay, so the combination of like the old stuff, the new stuff, and this. Sonia, you talked about, I should say, like that's like our Sonia music, that's our Sonia Arctic, if you're referencing to somebody. Sonia Arctic. So people up there are very clearly having challenges with this one, but we could also see that there are new solutions coming out of this. So challenge or opportunity?
Yeah, I think that's the good way to look at it, because for me, well, first of all, I didn't look up the word evolution in a dictionary, but if I felt intuitively what it means to me, I would think that's the positive change. So that I would interpret as a positive thing. But in terms of a change that we observe in the Arctic, that one can be a bit tricky. If one is not prepared, then it can be perceived as quite a threat. But if we can kind of narrow down how the future is likely to look like, it can actually be as an opportunity to develop new ideas how to approach these changes and to learn to live with them. So that's why I tend to see and try to present it also as an opportunity to develop new ideas.
So after these initial thoughts from you 3, were there any questions, similar ideas, completely different ideas coming up when you were talking at the table? There was a hand very quickly.
Stop calling it good and bad once and for all. Evolution, I mean, it's this is a very anthropocentric way of looking at it. I mean, kind of, but yeah. Just like a cancer cell, right? I mean, acquiring immortality because you've shut down P53, cool, that's good for you as a cancer. It's pretty bad for the human organism who suddenly gets a tumor. So I would kind of like to refer to a talk of François Jacob in 1977 where he said evolution and tinkering. So
can you say this again? Evolution
and tinkering. So evolution and tinkering. doesn't have good or bad. It doesn't have a project, a plan, what it's doing. But it's just doing with whatever is lying around.
If I may take this one up, your comment, I have a good question, mostly, or actually for the three of you. Is it an active or a passive thing, evolution and changes?
It's a random thing.
Yeah.
There's a random thing, but for example, you are an artist, you make up the music, so you think about what you're doing. So is this change, how we experience your music piece, active or passive?
I mean, it kind of get kind of both, because in my case, right, there are many people doing different things, but triggered by feelings. That's a passive thing, right? That's, you get like this kind of feeling, and then you actively do something, so it will be like kind of both at the same time. So yeah, random will be like the best word.
I hope you didn't do it randomly before.
No.
I think you had quite a plan what you would be playing tonight.
Yeah.
Yes.
Yeah.
Sonia, in Arctic, Sonia, in the Arctic, like we know, like the climate's reacting maybe randomly to it, but did we take a control over this? Would you dare to say something about this one? How did it change?
We are getting way deep here.
Another cocktail?
You have your beer ready? Maybe for the deepness.
Yeah, well. Well, first of all, I was afraid to put any climate in my talk because I'm not a climate scientist. I dig in the dirt, and I really just I look at the reaction of the ground to the changes in the climate, and I think those changes go both ways. So we are looking at the interactions. Really.
So again, both ways. Everybody, yes, there was directly.
Yeah, I very much agree with not calling evolution bad or good, because it's like, are gravity bad or good? It's a fact of life. It's what happens to us. It is what we are doing with it that can be bad or good. And then I would like to ask a question: is evolution competition or collaboration? What do you think?
I think collaboration.
Competition.
So you should say both now, then we are completely even.
Shouldn't take sides, right?
But please elaborate if you want to.
Thinking about bacteria that you said before, the stronger survives. So in that case, evolution is
What about the
competition.
eukaryotes? It's a collaboration between two very different bacteria, and they survived.
And we have mitochondria, and we hatch
Yeah.
incorporated bacteria. So, yeah.
But there's no Frodo-gene because he dies in the end, right? So
what?
There's no Frodo-gene because he dies in the end, right? So it's still.
But so you had a different approach, like a different answer to this one.
No, I see it like a collaboration. Like, okay, I'm taking something
I do
and
too.
yeah. Yeah.
Why do you think it's a collaboration?
Because it's not like, oh, I have these things, I'm gonna try to be better. It's like I have this thing, and I can adopt it, and improve it some way. So it's a collaboration.
And I would say so with the bacteria, that's the thing the bacteria do, because when they want to get better, they borrow DNA from other bacteria, and that's the way they are doing it. That's what we see at the hospitals, and that's terrible because it's antibiotic resistant. They're borrowing. But
So I want to say, like, the bacteria are learning somehow how to adapt.
they are using each other's DNAs to collaborate to be better.
So Sonia, how do people learn? Arctic Sonia? Arctic Sonia, how do people learn to adapt? Because you showed there were different solutions, different possibilities how people can react if they are forced to change. But how do they learn? How do they know about how they can change something?
I would say it seems to be pretty much by trial and error. So in that case, it would lean more towards a competition of the better idea or the more successful idea that wins. But I think we are in a really different concept in this one.
Is there somebody else who has a question here? No. Then maybe I try to take a different. Oh, was there some? There was something. Sorry.
Evolution is such a broad
Yes.
term that it depends where you look at from, that it can be good or bad, but it depends where you look from.
Yes.
Maybe if you look at the animals, they maybe don't think evolution is so great because what we're doing with the planet right now, it's not very smart. So like it always just depends where from what angle you look at. That's what I just wanted to see. So it's just a very broad, not black and white question. Yeah. like you can't have a black and white answer to a black and white question. So
Yes.
it's just very.
And that's something I can share, that when we were talking quickly here, just these 2 minutes while you also were discussing, where the immediate answer was also like, well, it's like 50 shades of gray or whatever. But many different shades we have to look into. Yes, that's very true. Thank you. So maybe get something different to both Soňas as an artist, musician, and as an Arctic researcher. When discovering something new, because you maybe discover a new melody, something you like, or you discover a new environment, a new circumstance there, where do you start to look for something new? Where you get inspiration and where you get your research idea? Don't know if there's any of.
I have to think about that one.
I think for me it's there are 2 things. One of them, I think the one I enjoy the most is spending time in the environment and spending time with the people. Like in my case, when it was easier to travel, I would spend around 3 to 4 months a year in Greenland on some years. And it's when you have that amount of time, you really get to see a little bit more of how people live their lives, and you get to talk to them. And then you see the problems that they have, or things that don't work so well. So I think a lot of inspiration and actually a lot of motivation for research comes from there for me. Mm-hmm. And then it's also definitely talking with inspiring people. So it can be researchers, it could be people just from it could be artists, it could be people from completely different walks of life who just have a fresh way of thinking. Mm-hmm. Because that can, you never know, things are connected, and their idea can just inspire.
So by listening to other people, listening to other ideas?
Listening or just an active conversation, I think that is very inspiring.
Mm-hmm. Do you, Soňa, music, get inspiration from similar origins?
To that, her explanation, like you get an idea, you might get some chords or like a random melody, and then of course you will have some influences from favorite people. Let's kind of say, was like, oh, that's a very cool rhythm. What about if I introduce it in here? So it's all about like getting, recruiting other ideas, maybe trying it on your own, and just building up from there.
Mm-hmm. Mm-hmm. Any comments, questions from somebody? No. Yes, there.
So do you think it would be, now we're talking about like overcoming obstacles and collaborations and way to be influenced. Do you think there's any way that art and the different sciences can influence each other? Like now you worked up to this event, you come from very different disciplines, from music to bioinformatics and so. Has it inspired you in any way, or has it like confirmed that, okay, stay in my lane and listen to more music, less scientists?
No, but that's a very valid question. Actually, I did my performance with them. So I knew what he was talking about, I knew what she was talking about, and my goal was to be a bridge between one speaker and the other. And so the science influence or inspired the thing that you just saw here. But yeah.
And I have actual opinion on that, because it's really not 2 separate things. I don't know how many of you actually are working science or have, but many people I meet in the university environment or in research, they have oftentimes they're very intensely into their hobbies that are art and music. There are so many passionate, especially musicians in the researchers I know. So I think it may be because there are some parallels in a way that one thinks in research and in music. I mean, you need a lot of similar competencies in both. You need to have your own fresh ideas. You need to be innovative. You have to be willing to try new things, to fail, to improve, to build upon what you did before. So I think as surprising as it may sound at the first thought, for me, science and arts are actually very similar in a way that people think, just applied to different creative pursuits.
So like in a meta method kind of way.
Yeah,
you have to do the same thing.
Mm-hmm. And I'm a bit too tipsy to answer this. I was not lying before. Go to them. Just smiling and not.
Yes. I don't know if there are any more questions anywhere in the audience right now. If you come at some point during this evening still to some ideas, I just want to say, like, we are still here. We're going to hang out a little bit more here in our corner at the bar. Please approach all of them, approach some of us. We are very happy to engage and to keep talking. with this being said, I want to thank all of you for coming tonight, and the one that stayed even to this discussion here, thank you for staying so long. It's great to see so many faces here, also very engaged people here. I hope you had some fun. I hope that you could get somehow inspired. We heard this whole evolution's not black and white, it's many between this. I think that's a beautiful thought that we can take away from here. And maybe accidentally you even learned something tonight, and I would be very happy if that's the case. Then I want to say thank you for our speakers. Thank you for taking the time tonight to be here. Thank you for making these performances. So I think they deserve just for this an applause. Yes, they should be there. No? No? Yes! Thank you for bridging my confusion with our applause. Some chocolate for you, because I think all of you used all of your brain for making this, and you need to replenish. I said this at the beginning, I say it again, we are very happy for any feedback, what went well, what did not went so well, so please still fill in the QR codes. If you want to fill in the QR codes, let us know what's good, what's not so good. Then we are still growing, like BluBulB is a new thing, we still need followers on Instagram, Twitter and Facebook, and they will be at some point behind me again, so you really help us by following our channels. Also tell your friends, tell your family, tell anybody that you know if you liked it tonight. Also tell them if you didn't like it tonight, they should come around, like we are happy for everybody here. And then I can tease, like we have one more event in roughly a month on the 21st of June. We're going to have an event at the same time, at the same place, and next time we're going to talk about communication. So we're going to hear something about signals running in the body. We're going to have a comedian on stage. And we're going to hear something about space and the origin of our planet. Well, if this is not interesting, I don't know what is. Maybe evolution is equally interesting, I would say. My name is Sebastian. BluBulB is organized together with my colleagues Moreno sitting there and Leonardo, who drew all of this. Thank you, everybody, for coming tonight. Thank you, guys.